Okay, guys, let's add this information to what we did in class today on 6.3. The title is Binomial Radical Expressions. So what that means is you have an expression where you're adding two terms with radicals. And we did a little bit of that today in class when we combined like radicals. We're going to add to that now. One of your problems for tonight asks you to find the perimeter of a rectangular shape that's made up of squares. The challenging part of that is that some of the perimeter of the rectangle you're trying to find is made up by not the sides of a square but the diagonal of a square. So the idea is if we have a square where all sides are equal in length, we know the measure of each side as long as we're given the measure of at least one side. What we don't know is the diagonal. And a lot of the time with squares, people believe that the diagonal is the same length as the side, but that's not true. What is true is that there's always a ratio of lengths. If you take two sides of a square and the diagonal, the ratio of the side lengths is always the same. The perimeter of the square have a measure. Let's say it's 1. Well, that means that the measure of the diagonal is the square root of 2. And the way we know that is by using Pythagorean's theorem, which states that if you have one of the legs of a right triangle and you add it to another leg of that triangle, squaring both terms, you're going to get the hypotenuse term squared. So that means 1 squared plus 1 squared should equal the hypotenuse squared. Well, 1 plus 1 equals 2. And we know that the square root of 2 equals c in this case, or the hypotenuse. So if you're given a square, let's say that's a square, and you know the side length, say the side length is 5, well, you know the ratio of sides for a right triangle. That's a 45, 45, 90 right triangle are always side to side root 2. So here, if the perimeter of the rectangle is 5, we know that the diagonal of that, I said rectangle but square, is 5 root 2. So that should be helpful in helping you to determine what's the length of the diagonal of the squares that you're using to find the perimeter of the rectangle. If it's not, I guess we'll go over it more tomorrow. Good way to think about it is side length, and the diagonal is always the side length times the square root of 2. Okay, for our next example, let's look at adding two roots. So this is a binomial radical expression. We want to be able to find the simplified form of each of these roots. So we're going to take the largest perfect square that goes into 12, which is 4, because 4 times 3 is 12. And we want to find the largest perfect square that goes into 75, and I think that's 25. 25 times 3. So So square root of 25 times square root of 3. This simplifies to 2 root 3 and 5 root 3. When the expression wasn't in its most simple terms, it was more difficult to see that the expression could be further simplified. But once we put the expression in simplified terms, it's easier to see that we can combine these terms because they have the same index and the same radicand. They're both square roots, and they both have 3 as their radicand. So their sum is 7 root 3. So don't give up right away if you aren't dealing with radicals with perfect squares. You may just be able to use perfect squares to further simplify those radicals in an expression. Moving on to the next example. Sometimes it's the case that we want to multiply binomial radical expressions. So one example would be 4 plus 2 root 2. So that's a binomial radical expression because you have two terms that are being added, and at least one of those terms is a radical. You multiply that, 5 plus 4 root 2. So we have two values here being multiplied with each of those values having a radical in them. You might remember foiling in Algebra 2 earlier, or Algebra 1. We're going to do the same thing here. We're going to take the first term and multiply it by the first term in the other set of parentheses. We're going to take the two outside terms and multiply them by each other. Then we're going to take the two inside terms and multiply them by each other. And then we're going to take the two last terms and multiply them by each other. So what does that give us? That gives us 4 times 5 plus 4 times 4 root 2 plus 5 times 2 root 2 plus 2 root 2 times 4 root 2. This simplifies to 20 plus 16 root 2 plus 10 root 2 plus 16. It's okay for us to multiply the terms that are outside of the radical. The term that's right in front of the radical is not married to the radical. It's okay to multiply it by another term as long as there's all multiplication in the expression. Okay, let's continue to simplify. We have two radicals with the same index and the same radicand, so we can add them together. We can also add together the two constants. So that's how you multiply binomials of radical expressions. You're basically using the FOIL method to do that. And then identify the radicals that you can combine because they have the same index and the same radicand. Pretty useful. In class tomorrow, we'll go over multiplying conjugates and rationalizing the denominator using conjugates.